Well, good morning from Steinbach, everyone. I know I introduced this idea to you yesterday, but I thought that, excuse me, I would take a moment and work a quick example for you on off of exercise 19. So today we're going to take a look at the sine law. Now, if you get your exercise books open and you take a look at the first question, it'll look like this. And now this is the fairly typical sine law sort of triangle. Now, only the first two exercises in your, questions in your exercise are going to look like this. After this, they're going to describe the triangle for you, which means you have to draw it and label the corners with capital letters, the sides with lowercase, and work on using the sine law with your diagram. So first of all, let's take a look at what specifically the sine law is. Okay, what the sine law says is that if we take the sine of an angle A and we divide it by the side of A, and we can set that equal to the sine of the angle B divided by the side opposite it. Now, a lot of times they'll say also that the sine of angle C be divided by the side C like this. Now, specifically, you have to have a triangle drawn, something like this, to be able to see what's going on. Now, you label your corners with capital letters like so, and the side opposite the corner is the lowercase, like that. So this would be side B, and this would be side lowercase c. Alright, so knowing this, let's go back to our first question from exercise 19 and take a look. So here we have the side x right here that we're looking for. Now you can flip this around, but for now let's leave it alone. Let's say that this is going to be the sine of 67, and I chose 67. I'm just going to show you here this angle because it's opposite of the side we're trying to find. So the sine of 67 degrees divided by x is going to equal the sine of 73 degrees divided by the length of the side opposite it. That is 42. Okay, now what we're ready to do is solve for x. So what I'm going to do here is I'm going to multiply both sides by 42 to begin with, and I'm left with 42 times the sine of 67 degrees divided by x equals, and of course these 42's divide out to equal 1, and this is going to equal the sine of 73 degrees. Now I have to isolate my x, so I just multiply both sides by x. These x's divide out to give me 1. I have that 42 times the sine of 67 degrees is going to equal x times the sine of 73 degrees. Okay, so we'll scroll down just a little bit to give ourselves a bit more room. And now we're going to divide both sides by the sine of 73 degrees so that we have x all by itself, like so. So we can use degree symbols. And we're left with x equal 42 times the sine of 67 divided by the sine of 73. Now, if you get this far in the problem, you're doing wonderfully for your first day. Now, using the calculator to calculate this can be a bit tricky, and it takes some getting used to. So what I'm going to do here is I'm just going to pull up my calculator, and we're going to find some decimals. So first of all, let's find the sine of 67 degrees. We're going to make sure that we're in degrees here. So make sure you do that. And we're just going to take the sine of that. And we can see that we've got 0.90 sorry, 9205. So 42 times 0.9205, like this. Now, we're going to find the sine of 73 degrees, so there's 73. Take the sine, and that's 0.9563. 0.9563. And now what's left is a little multiplication. So we pull the calculator up again. We're going to take 42, we're going to multiply it by 0.9205 equals, and then we divide by 0.9563, and there's my answer. The side length is 40.4 units. A little box around that, and we're all done. Now, what I'm going to do here is I'll just pull up our cumulative exercises, and I'm going to zoom out a little bit here. Around about question 3 here, and we'll zoom in just a bit. There we go. You can see that you're having to draw your own triangles. So I want to see if I can copy this and bring it back in. Let's paste it in here. There we go. And let's just take a moment to show you how I do this. Now, even though it may not turn out to be right, I generally draw my triangles all like this, kind of looking like equilaterals, but not quite. I start with calling this corner A, this is going to be corner B, this is going to be corner C. I pretty much always do that. Now I start labeling my corners and sides. That's going to be 44 degrees. This is going to be 71 degrees. This side is 5.4, and this side is the side that we are looking for. Now, this is fairly typical of a problem. You see, we have this, but we have this angle and no side, and we have this side but no angle. Not to worry, all of the angles you'll remember in a triangle have to add up to 180. So 44 and 71 gives me, there's the 5, there's 115 degrees. So that means that if I take 180 and I subtract the other two angles, I'm going to be left with, let's see, that should be 65 degrees, like so. Now I'm ready to do my sine law. Sometimes there's a little bit of geometry involved with these first. So, the sine of 44 over b is going to equal the sine of 65 over 5.4. So, that's how you set up the sine law for a triangle that's either defined for you like this, or if it's drawn out for you like that. You can replay this part to see the solution. Solving for the side is always a little tricky. Best of luck, and when I get back on Monday, we'll see how you did. Thanks.